Welcome to The Explainer. Today, we're diving into a question that sounds simple, but is actually, incredibly deep. Do numbers have a world of their own? We're talking about the very nature of mathematical reality. So, let's get right into it.
Okay, so think about this for a second. You can see 3 apples on a table, right? You can hold 3 coins in your hand. But where is the number 3 itself? Can you actually point to it?
No, you can't, can you? It isn't a physical thing you can kick or touch, but it's also not just some private idea floating around in your head. Because you and I, and frankly everyone on the planet, we all agree on what the number 3 is. It's totally objective, but it's not here. So, where is it?
Well, this exact puzzle is what leads philosophers to talk about abstract objects. This is a category for things like numbers, sure, but also perfect geometric shapes or mathematical sets. The whole idea is that they exist for real, but just not in our physical space and time. They're completely non-physical, non-mental, and totally timeless.
And here is the absolute crucial difference. Physical objects, like this apple, exist in space and time, and they have causal powers. They can affect other things. But abstract objects, they're the complete opposite. They exist outside of space and time, and get this, they're causally inert. That just means they can't push or pull or change anything in our universe. Now, this point right here is the key to the entire puzzle, so keep it locked in.
So, if these abstract numbers and shapes are real, but they're not here with us, where are they? Well, an ancient and really powerful answer comes from the philosopher Plato.
This view, it's called mathematical Platonism, or sometimes realism. And it's the idea that mathematical objects aren't just real, but they exist completely independently of us humans. They were here long before we showed up, and they'll be here long after we're gone.
So Platonism says that numbers live in this perfect, eternal, unchanging, abstract realm, kind of like a Plato's heaven. And in this view, mathematicians aren't inventing a single thing. No, they're more like explorers, discovering the timeless truths of a hidden reality. And honestly, this really seems to match the gut feeling of a lot of working mathematicians.
Okay, but as neat and tidy as Platonism sounds, it slams right into a massive philosophical problem. A problem that has pretty much defined this whole debate ever since.
Let's just start with a fact that nobody can argue with. We know things about mathematics, right? We know that 2 + 2 = 4. We can prove incredibly complex theorems. We can solve equations. Mathematical knowledge is a real thing.
Now think about how you know, well, anything else about the world. To know there's a star in the sky, light from that star has to travel millions of years, enter your eye, and hit your retina. To know about a dinosaur, you have to dig up a fossil and observe it. Our knowledge of the physical world always requires some kind of causal interaction, no matter how indirect it is.
And here's where it all comes crashing down. Remember what he said about abstract objects? They're causally inert. If numbers are locked away in this perfect Platonic realm, totally cut off from our universe, they can't send us any signals. They can't affect our brains or our scientific instruments in any way, shape, or form.
And there it is. That's the killer question. If we can't interact with mathematical objects, even in principle, how on earth can we possibly know anything about them? This is the huge challenge to Platonism, famously laid out by the philosopher Paul Benacerraf.
Benacerraf's challenge was such a bombshell that it forced philosophers to come up with totally different ways of thinking about math, ways that don't depend on us having some kind of mystical hotline to a separate, causally isolated realm.
So the rivals to Platonism try to fix this knowing problem by taking a different route. Instead of saying math lives in a separate reality, they try to locate it somewhere else entirely. Maybe it's just a game of symbols, or a construction of our minds, or maybe it's just about the patterns themselves. Let's take a quick look at the 3 biggest rivals.
And these competing theories are just fascinating. So first you've got formalism, which sees math as this giant superlogical game of symbols and rules. Mathematical truth is really just about playing the game consistently without contradicting yourself. Then you have intuitionism, which argues that math is purely a mental construction. A number, or a shape, only exists if we can actively build it in our minds.
And then a more modern view, structuralism, says math is the science of patterns. The number 3 isn't a thing at all. It's just a place, the third position in the overall structure of all the numbers.
So you've got Platonism's timeless heaven, formalism's logical game, intuitionism's mental constructs, and structuralism's web of patterns. Which one's right? The honest answer is, we don't know. The debate is just as alive and kicking today as it's ever been.
Every single one of these views has some really powerful arguments going for it, but each one also faces some serious challenges. And that tells you something truly profound. The very foundations of mathematics, the thing that seems like the most certain knowledge we have, are actually built on philosophical ground that's still shifting under our feet.
And this deep philosophical mystery links up with another, maybe even bigger mystery. It's often called the unreasonable effectiveness of mathematics. Why? Why does this abstract world of patterns and structures, whether it's real or we invented it, describe our physical universe with such jaw-dropping precision? From the orbits of planets to the weirdness of quantum mechanics, math is just the language of reality. How is that possible?
So in the end, the whole debate really boils down to this one epic question. Are mathematicians more like astronomers, peering through a telescope to discover timeless truths that have always been out there waiting for us? Or are they more like composers, inventing the most powerful, intricate, and beautiful game humanity has ever conceived? The answer, well, it remains one of philosophy's greatest and most fascinating open questions.